All right, good afternoon, everybody. Today we're going to go through Chapter 4, Lesson 2, and our topic will be relations. This is again building towards our Chapter 4 topic of functions, which we will talk about in the next lesson. But today we are talking about relations. So just to get us started up, we want to do a vocabulary startup. We want to complete this graphic organizer. So the first thing is we want to go through and label our quadrants. If you guys remember, this is our first quadrant, second quadrant, third quadrant, and your fourth quadrant. Okay, so those are how you label the quadrants. Over here, this first point up here is pointing to the point right in the middle. We call that the origin. That is where everything starts from. That's our starting point. Over here, this line is pointing right here to this line that runs right through the center, left and right or horizontally, and that would be our x-axis. And then this one, conversely, would be the y-axis. The vertical or the up and down line would be the y-axis. Then it's asking us to identify this point here. So the way that we do that, remember, it's always x comma y in alphabetical order. So how far do we move on the x? That would be -4. And then how far do we move on the y? That would be a +3. So 4, 3. Down at the bottom it says identify the coordinate in the point -5, -7, or identify the x coordinate. So remember, it's just alphabetical order when we deal with ordered pairs, x comma y. So the x coordinate would be this -5 right there. So our key concept for today in our unit about relations is a relation. So a relation is any set of ordered pairs. Relations can be represented as a table, which we see right up here, as a graph, which we see over here, or as a set of ordered pairs. Okay, because that's what it started with. A set of ordered pairs right here are our set of ordered pairs. We put them into a table, and then we put them on the graph as x's and y's. The domain of a relation is the set of the x-coordinates. So the x-coordinate is the domain. Sometimes we call these the input values. Those are what we plug in to our equations. So the domain is the x values, and the range of a relation is all the set of the y-coordinates. So all these ones right here are then the range. Domain and range. So continuing on with relations, the domain is all the x values and the range is all the y. Over on to example number 1. It says express the relation as a table and a graph, then state the domain and range. So the first thing we want to do is express it as a table, and we could just make a simple xy chart. X on one side, y on the other, and then you just list all of your points in there. 2 goes with 6, -4 with -8, -3 with a +6, 0 with a -4. Okay, so that's our table right there. That part's done. Now we want to express it as a graph. So in order to graph it, we just plot the points on the graph. 2, 6, 1, 2, 1, 2, 3, 4, 5, 6. Put a dot. -4, -8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. All the way down there. -3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 0, -4. And that's all of them. So that would be the graph of our relation. Okay, we're just putting the ordered pairs on the graph. So then it says state the domain and range. It's a very specific way we want to do that. We want to say capital D for domain. We're going to put a colon, and then we're going to use braces. Okay, braces are what you see right here. They're used to denote sets. Sets can be numbers or ordered pairs or anything really. The cheater way, if you can't make nice ones, is to go C, V, C. That's a brace. And then we're going to put all of our x values in there. 2, -4, -3, 0. And then close it off on the other side, C, V, C. And that is your domain. We do the same thing with the range. Capital R for the range. brace, 6, -8, and -4. Now it's very important that when we talk about the domain and range, we don't need to put any repeats in there. So the domain are all the x values minus any repeats. Okay. Down here, our little sticky note to give us some advice. It says if the term in the domain or range appears more than once, only write it one time. And that's exactly what I was talking about with the repeats. In example 1, the value 6 appears twice in the range. So that's why we only need to write it one time. So we want to write everything in all the x's with no repeats, all the y's with no repeats. Go ahead and pause the video and go through example A on your own. Take a minute. And we should be back from trying example A, or the got it section number A on your own. So quickly, the x in our chart are just all the x values. -5, 3, 6, 1. And the y's 2, -1, 2, 7. Now it's important that when we're making a table, we write all of our values. It's only when we write the domain and range that we don't keep the repeats. So to put it on the graph, -5. Let's see, it looks like we're going by 2, so -5 would be there. +2 right there. 3, -1 right there. 6, 2, 2, 4, 6 up 2, and 1, 7 be about right there. So there's our graph. Finally, it says state the domain and the range. So the domain D : brace -5, 3, 6, 1 brace. The range capital R : CVC 2, -1. I don't include the repeat, and 7. So that would be my domain and range. Moving on to example number 2. Now we have more of a real life situation. So it costs $3 per hour to park at the Wildwood Amusement Park. Make a table of ordered pairs in which the x-coordinate represents the hours and the y represents the total cost for 3, 4, 5, and 6. So here's x, here's y. X represented hours, and y represented cost. So pretty simple here. If we want our hours to be 3, 4, 5, and 6, and it costs $3 per hour, well, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 6 times 3 is 18. Okay, so there's our table. Okay, and then part B, it says graph the ordered pairs. So here we're going to have to go by 2's in order to get this number 18 and 15 and everything to fit on there. So 3, 9 would be 2, 3, 2, 4, 6, 8, 9 right there. 4, 12, 2, 4. Let's see, 2, 4, 6, 8, 10, 12. 5, 15. 2, 4, 5. 2, 4, 6, 8, 10, 12, 14, 15. And 6, 18. 2, 4, 6. 2, 4, 6, 8, 10, 12, 14, 16, 18. Right there. So that would be our ordered pairs in that relation. Okay. Go ahead and try the next one on your own about a movie rental store under the Got It section, B and C. Okay, we should be back from trying this one on our own. Let's go through the answers. So if a movie rental store charges $3.95 per movie rental, then we need to make a table for 1, 2, 3, and 4 movies. So again, we can just start with an XY chart. X, Y. Our X's are 1, 2, 3, and 4. And we always plug into the X. That's our input value. And all we need to do is multiply them by 3.95 in order to find out the cost per movie. So 3.95. And then 3.95 times 2 is 7.9. 3.95 times 3 is 11.85. 3.95 times 4 is 15.8. There's our table. It's as simple as that. Okay, and then it says graph the ordered pairs. So remember, our x represents the number of movies. So down on the x-axis down here, I should have the number of movies. And then over on our y-coordinate represents the total cost. So on the y-axis, I should have total cost. So if I plug in our ordered pairs here and graph them, for one movie, it costs $3.95, which is just about 4. For 2 movies, it costs $7.90, which is just about 8. For 3 movies, it's $11.85, about there. 4 movies, 15.8, right in about, oops, it's the wrong line. Right in about there. Okay. So you just graph your points on the graph, and that's really about all there is to relations. The key thing here moving forward is that we understand that the x values are the domain of the relation, and the y values represent the range. Okay. And a relation is a set of ordered pairs. So if you ask what is a relation, it's a set of ordered pairs. Okay, so here is your assignment. We're on page 281. Red, yellow, green. If you understood everything, do the green. If you understood some parts, do the yellow. And if you were struggling today, do the red. Okay. That's all I have. If you have any questions, come see me in the morning or during my time. Otherwise, have a great day.